Hello guys, look at this one called writing an equation of a circle and identifying points that lie on the circle. This is my favorite one from this week. This is my favorite exercise um, because it is very I don't know how to say this. You can tell what is the meaning of all of this about equations and figures in analytic geometry by trying to solve the equation with the points given, and you will see that the points that are going to be in the circle or on the circle are going to be the points, the coordinates that when you substitute the values, then you have an equation that is true, something that is true. Okay, let's look at this. Consider the circle centered at the origin. We have done this before. The origin is 0, comma 0. So that means that h is 0 and k is 0, right? Now it says that the radius is 6 already. So this is going to be very easy because the standard form of the equation of a circle is this. So if we substitute things, x minus 0 is x squared plus y minus 0 squared is y squared. Now 6, that is the radius squared, that is 36. So the first part is really easy using the standard form of the equation of the circle. Now, this is the interesting part. Let's think about the circle. This is the center at the origin. This is 6, minus 6, 6, and minus 6. So the circle is, oh, that looks like a 0. The circle is going to be something like this, right? Sorry if it doesn't look like a circle. But okay, think about this. 0, comma minus 6, 0, comma minus 6. I know my circle does not pass through that point, but it should. So this should be in the circle, right? The idea is you don't have to do the drawing because there will be points that are going to be not so easy to graph. What you're going to do is substitute the value of the x and the y in the equation and see if you get x is 0 and see if you get something true. Y is minus 6. So if we make these calculations, 0 squared is 0, minus 6 squared is 36. So 36 equals 36. That is true. So this is going to be in the circle, right? Let's do the same thing for the other ones. I'm just going to do one by one. This has to be 2 squared plus the square root of 13 squared, and that should be equal to 36. 2 squared is 4. The square root of 13 squared is 13. And that, it's so sad, but because 17 is not the same as a 36, is it? 36. So this is false. This is not in the circle. And I don't know how much is minus 13. I know how much is the square root of 13. It has to be more or less like a little bit more than 3, like 3.5. That should be like 2, comma 3.5. That it should be like here. So this is not over the circle, right? Over the circumference. So it makes sense that it is not in the circle. Right. Now I wish I can erase only that part. The square root of 11 squared plus minus 1 squared has to be equal to 36. This is 11 plus 1, and that is 12, and 12 is not the same thing as 36, so this is false. Again, the square root of 11 has to be 3 point something, 3 point something, 1, 2, 3 point something, comma minus 1. No, this is not in the over the circle. That is not over the circle. We have demonstrated that analytically. That is why this is interesting, because we are working with figures analytically, analytical geometry. Now 3, 0, you can tell this is not going to be in the circle because 9 is not the same as 36. So this is not in the circle either. Thanks.